Hello and welcome to another session in physics. In this session we'll be looking at the topic heat transfer through processes such as conduction, convection, radiation, and their various applications. But before that, let us review the previous lesson. Welcome back. At this point, I'd like us to talk more about the ways through which heat can be transferred and the applications, like I stated earlier, using processes such as conduction, convection, and radiation. From the diagram you see here, you would notice that this is the diagram of a pot on fire. Now, heat can be transferred through the following ways. When a pot is on fire and you're holding it, the truth is that after some time, you would not be able to hold the handle of that pot again. The reason is because your hand would get hot as a result of the transfer of heat by conduction. So naturally, it is the base of this pot that is on the fire or on the stove here. But after some time, due to the metallic nature of this pot, heat is going to spread by conduction to all the other handles that are metals, because iron or steel is a good conductor of heat. And we all know that when something is a conductor of heat, that thing can also conduct electricity at the same time. And the human body is also a good conductor of heat and electricity at the same time. So when you hold it, you're bound to feel some level of heat in your hand. And if you're not careful, you could get injured. That's an example of heat by conduction. And then what about convection? You would notice that there is some water inside this pot. Now, as this water continues to boil, it boils to a point where the heated molecules are evenly distributed. Remember, it is the water concentrated at the bottom that is heated. But by virtue of diffusion, where these heated molecules tend to go from areas of lower concentration to areas of higher concentration, the ones that are cold at the top will start to come lower to tap from the heat energy of that which is dwelling underneath. And by convection, before you know it, after some time, the entirety of the water inside this pot will certainly get hot. And then by radiation, if this pot is lifted a little, you would notice that you will still feel some heat. Even though you're not in contact with the fire, your hand will still feel hot because you're still very close to the stove. Now, how does the heat from this stove get close to your body? It is by radiation. It is the same principle by which the energy from the sun, solar energy from the sun, heat energy from the sun, gets to us here on earth. Even though we do not touch the sun, but we still feel heat from the sun. That is through radiation. So we're going to look at these three means of heat energy transfer and how they are being harnessed today. So by extension, when we talk about conduction, we're simply referring to the process of transfer of heat through a material by the vibration of the molecules that are fixed in position. Like we explained earlier, through the handle of this pot, it is actually easier to transfer heat by conduction. Note, like I also said earlier, that metals that allow heat to pass through them are said to be good conductors of heat. Though all metals are classified as good conductors, but the truth is that they differ in their ability to conduct heat, which means that some metals are actually very excellent conductors of heat, while other metals conduct heat but not so excellently. And we also have non-metals such as wood and plastic. They are known as insulators because they do not allow the flow of electric current through them. As a result of that, they are bad conductors of heat, and they also do not allow heat to pass through them. This explains why they deteriorate either by burning. When you put wood into a fire and expose it to heating, it's going to get burnt and turn into charcoal. Plastic, on the other hand, will melt and turn to ash. Additionally, thermal conductivity is simply the ability of a metal to conduct heat. So when you talk about thermal conductivity, it simply refers to the ability of a metal to conduct and dissipate heat. Now let's look at the practical application of conduction of heat. And you know full well that when we have things like kettles and things like pans and other utensils we have in our houses, these utensils are made from metals, and because they are made from metals, they are not necessarily designed to have metal handles. They are designed to have wooden handles, either wooden or ebonite handles. These wooden or ebonite handles helps to make it safe for us to handle them, so that heat would not flow so comfortably from the utensil to the handle itself, and you have to find it difficult to bring the pot down from the fire. So that's one application of conduction of heat. Pots and other things made of metals have wooden handles so that heat is not conducted. Another second application of conduction of heat is where we have things like household saucepans. We have things like household saucepans, and these household saucepans are made from metals. They are made from metals, and because they are made from metals, they are very good conductors of electricity. They conduct electricity easily. I want to reiterate once again that good conductors of electricity are also good conductors of heat. So if something can let electricity pass through it, then most definitely it's going to allow heat to pass through it as well. Another practical application of the conduction of heat is found in thick brick walls that are used in storage rooms. Thick brick walls used in storage rooms. You know that bricks are very bad conductors of electricity. They do not allow electricity to pass through them. So what happens, and the reason why bricks are used for storage rooms, is that they will not allow heat to enter the storage room. They allow heat not to enter into the storage room. The reason for this is that if heat were to permeate into the storage room, it might actually lead to the deterioration of the materials that are being stored in that storage room. And now a fourth practical application of this is why a stone floor feels colder to the feet than a rug or carpet would. A stone floor will feel colder to the feet than a rug or carpet would on the same floor. I've actually seen a question like this in WAEC where they ask students, why would a stone floor feel colder to the feet than a rug or carpet would? The reason is because a stone floor is a very good conductor of heat. It is a good conductor of heat. So when you stand on a stone floor, what happens is that the stone floor is trying to conduct heat away from your feet. As it is trying to conduct heat away from your feet by the process of diffusion, what happens is that your leg starts to feel colder and colder until you have no other choice than to put on some slippers or shoes to avoid your leg from feeling too cold. On the other hand, a carpet or rug is a poor conductor of heat. This way, the rug or carpet only seeks to retain the heat in your feet. It retains the heat in your feet. So because of that, when you stand on a carpet or a rug, you definitely feel warm. At this point, let us talk about convection. Convection is quite different from conduction, because conduction is all about the material medium itself, such as the pan. But convection has more to do with the fluid, what is contained inside the pan, whether it is a liquid or a gas. And we know that liquids and gases are made up of molecules. These molecules are in constant random movement and vibration. As a result of the actual movement of these heated molecules, what happens is that circulation occurs. And the circulation of this liquid actually results in the heating of the overall components of that liquid. And this is what we call convection current. Now let's look at the applications of convection, please. We have the first one, which is in the use of domestic water boilers. In domestic water boilers used in our homes, our offices, and so many other places, what they do is that when it is switched on, water is made to rush into this domestic water boiler. Initially, the water at the bottom of this boiler, probably at this level, seems to be the hottest, while the one at the top seems to have a little bit of coldness in it. As a result of the varying degrees of where they are situated and the distance they are from each other. But because the molecules are in constant random motion, they continue to vibrate within the container, and because of that, by convection, a current is set up where the hot particles will go up, the cold ones will come down. That is diffusion, where particles move from regions of lower concentration to regions of higher concentration. Alright, another application of convection is the cooling process of a motor car vehicle. This you see here is the engine of a car, and at the furthermost part of it here, you see this, which we call the radiator of this vehicle. Now, when you look at this vehicle very well, you would notice that when you put water inside the bonnet, inside this radiator here, it helps to improve the cooling system of the engine by convection, where cold water seems to settle at the bottom and then through a pipe goes into the pistons and other parts of the engine and helps to set up a convectional current that will actually help to cool the system of the car and stop it from overheating. And now we have this one that is so important: land and sea breeze. When it comes to land and sea breeze, it's actually very important that you know how convectional current is set up here. For sea breeze, notice that when it is the hot season, heat from the sun actually seems to pass straight through the air. Heat from the sun passes straight through the air with little effect. When this heat comes from the sun by radiation, what happens is that during this hot season, the land is heated up more quickly than the sea. The land becomes hotter. The land here becomes hotter than the sea. And the reason for this is because the sea isn't such a good absorber of heat, but the land is a good absorber of heat, and the land is also a very good radiator. But one funny thing is that the land has what we call low specific heat capacity. So what this means is that after some time, the air that is near the land will warm up. This air will warm up, and when this air warms up, it is going to rise up, while air from the sea, which was normally cold during the day, will now replace the air that has risen up. This cooler air will come from sea to land. That is why those who go to the beach actually feel cold. They feel the presence of cold air around them. This is because of a convectional current that has been set up between sea breeze and land breeze. So this air rises up, and the air from the sea, which is cold by the daytime, comes to replace it. Now, the air from the higher atmosphere moves from the sea, and a circulation current is then set up. The breeze from the sea is what we call sea breeze. It is that breeze that comes from the sea. On the other hand, during the night, you would notice that the land is not heated by the sun. Because the land is not heated by the sun, and because it is a very good absorber of heat, it tends to cool very quickly. It tends to cool very quickly. But remember that the land has low specific heat capacity, while the sea has a very high specific heat capacity. The sea has a high specific heat capacity. So because of this, the sea tends to retain more heat at night than in the daytime. And because of that, because this time around, the air that is on the sea is much warmer than that which is on the land, a convectional current is set up in the opposite direction. So the opposite of what happened in the daytime is what is happening now in the night time. And because of sea and breeze that is blowing from the land to the sea, this time around the sea feels warm, and this is called land breeze. This is called land breeze. Alright, at this point, let's look at convection in gases. When we talk about convection in gases, we're simply talking about the convectional current that is being set up to aid the movement or flow of gas materials such as smoke and other particles. And this is exactly what we're going to look at in our next lesson. Thank you for joining us in this lesson. To refresh your memory on what we've just discussed, please take the test that will appear on your screen.